Hello, welcome to Tech Dicted. Today we will be looking at mesh analysis where we will be determining the current flowing through the 4 ohm resistor. Okay, and so we may get started, but first I need to mention that you need knowledge on matrices, Kramers rule, and of course KVL. Okay, so we have tutorials on this and feel free to watch them before you proceed to this specific one. Yeah, so first we will find the equations of all the loops using KVL, whereby KVL states that the summation of voltage in a closed loop should be equal to 0, which means input minus what's consumed in the loop, input minus voltage drop equal to 0. So we have our input. Every resistor indicates a voltage drop because it consumes the voltage. Of course, there is some current being consumed by voltage being consumed, sorry. And so in this case, we can just first assume direction of current in all of this. So this is the direction I'm assuming, clockwise direction. You may assume it anyhow. What matters is how you'll use it, okay? So in this one, we've assumed current flows this way, and then down and to that side. Now, in an element, for example, a resistor, current flows from positive to negative, okay? So if we have current flowing this way, that means this will be positive and this will be negative. And so in this case, this will be positive, negative, positive, negative, positive, negative. And then in voltage, in a voltage source, for example, this, we have current. If current is flowing from negative to positive, then that's positive V. And then from positive to negative, then it will be negative V, negative voltage. So what this means will be that 12 will be just 12 because negative to positive, positive voltage, then minus voltage drop here, which is V is equals to IR, okay? So 2 and I, okay, we can assume this to be I1, I2, and I3. So 2I1, and then there's another voltage drop here. So plus, we are summing up all the voltage drops and then subtracting them from the input voltage. So plus 12, but there's something here. This 12 is at the border of I1 of these two loops, okay? So I2 flows this way, I1 flows going down, and therefore the current here is the difference between these two currents. Now, since we are in this first loop, then we start with that I1 minus I2, okay? If they were going on the same direction, then you would sum them up. Yeah. So plus this one, I. Okay, so now this is 1. We have also 2. Current is going the opposite direction. This will be positive, negative. Okay. And this means that the current here is the difference of the two. Therefore, I1 minus I3. And then when we sum all this, we should get 0. Okay. Now, 12, this is mesh 1. Before we proceed, let's just first of all write them all. Then for mesh 2, we have 10, okay? And let's see, current flows that way, that way, that way. Okay, so this is positive, negative, positive, negative. And then here we notice that positive to negative, okay? Current is flowing from the positive end to the negative end. Therefore, this means that this will be negative 10 minus Okay, now all this 2, we can start from this, so it will be 3. Again, we're in I2. This is going the opposite direction, meaning this will be 3 into I2 minus I3 plus 2. Is it 2 or 12? It's 12 plus 12. I have covered that one. So it's 12. 12 into, again, we're in this second loop, so I2 minus I1 plus 2I2 should be equal to 0. And now in this last one, this is mesh 2 equation. In the last one, this mesh, okay, current flows this way. So this is positive, negative. Then this way, from negative to positive. Negative to positive, we've said it's a positive voltage. So 24 minus, okay, again, opposite direction. So we subtract the current one, which is I3 minus I1 plus, again, we have a bigger bracket. So inside this bigger bracket, we have this plus, the second one, oh, again, okay, so it's 3 into I3 minus I2 plus 4 into positive to negative, and that's the only one, so I3 is equal to 0, and this is mesh 3. Okay, so once we have all this, then we can now start simplifying these equations, and then do matrices and apply Kramers rule. Okay, so Kramers rule, we first change this to matrix form, which will be okay, so these values, we place them here, and then the variables, and lastly this, yeah, just the same way as it is here. And therefore, remembering your matrices, this multiply by this should give you this first one, this multiply by this should give you the second one, and so on. Yeah, so now we can apply Kramers rule. Okay, so Kramers rule utilizes determinants of matrices, and therefore we will start by finding the matrix of the first one, which is this, and then we find the matrices when we change. So we replace these values here, then so on. Okay, so for this first one will be 17 times 8. This both are negative, so 136 minus 9. On this first one, let me explain, then on the rest you'll just replace and move on. Okay, so I'll go really fast on those so that we really don't use a lot of time. Yeah, so 13 minus 9, close this and close this. Okay, you apply it this way. On this second one, we close this, and so we're left with 12 times negative 8, and this. So this will be minus 12 times negative 8 minus, this should be 1. I don't know why. I think the I3 confused me. This should be 1 into Now we do this 12 times 3, 36 minus negative 17. Okay, so now we find the answer to be 136 minus, okay, let's just write this down, 1905 plus negative 96 minus 3 times 12. Minus 36 plus 17, 53. Okay, so our answer is minus 1188 minus 664. That's our first one. And so on the remaining ones, we replace these values here, and then here, and then on the last one. So for the remaining ones, the first one, by replacing here, will be 12, 10, negative 24. Okay, and then now we start with our calculation. So just the same principle. Okay, take this by this, take this by this. So that will be 12 into 136 minus 9 minus, okay, then when you simplify, okay, we don't even have to write everything, we just need to know this. Okay, and lastly, on our last three, we have 15, 12, 1, negative 12, negative 17, 3, 12, 10, 24. This is a negative 24. This is minus minus, so we can just put a plus here. Okay, if you simplify this, you get and lastly Okay, so once we have this, then we can get I1, I2, and I3. Now I1 will be equal to the determinant of this first one divided by this overall determinant, okay? I2, determinant of the second one, divided by that, and I3 the same thing, okay? So this will be, sorry for this, so this will be 1806 over 664. Then the second one will be 1366 over 664 and 2730 over 664. Finally, we have our answers as 1806 divided by 664, 2.7198 or 19 amps. Then 1366 divided by 664, 2 amps. 2730 divided by now looking at our equation, we had 4 here, okay, and only I3 passes through 4. That's why in this equation it was only 4I3, and therefore if we are asked determine the current through 4 ohm resistor, then that means I3, which is equal to I passing through the 4 ohm resistor, will be equal to 4.1114 amperes, and this is our answer. Okay, now in the case that you were asked current flowing through this, okay, you would do it differently, but since we were asked only for this, then it's basically I3. Okay, yeah, thank you, and let me see you in the next tutorial. It was a wonderful experience, and I hope you learned 1 or 2 things. Goodbye.